of you could be take the blue or the trash with you at home. So why can I talk about hybrid energy storage? I had 3 projects on hybrid energy storage, 1 German funded and 2 EU funded, which I wrote mostly the project proposal. And during my work, I worked somehow a lot with combinations of flow batteries with other storage solutions, either supercaps or other things. Roberto already showed a definition, which is very nice, but a bit too long, I think. So I showed the one which was in the Battery Europe position paper, which I think is definitely more battery related. Also, I have to say that today I will talk more about stationary energy storage, not about automotive, because I'm not qualified to do anything about drivetrains and anything. So I talk in general about, let's say, stationary battery storage. And of course, the important is to provide a benefit for the chosen application. This is, I think, the key word. And the question is, what is a benefit? And when is, when we do, is a hybrid storage a benefit? There we have to also say that classical hybridization is a system hybridization, so that you have 2 systems and make a complete management system. Of course, during the storage project, there are other types of hybridization where you can do, but I think the most commercial parts of hybrid energy storage is where you have 2 systems which you combine with a control system. So first of all, let me know a little bit more about my audience. Who actually is working in batteries? Hand up. Okay, it's really a lot. Who is working on battery materials of this? Yeah. Who is working on systems? Okay, so quite a few. So on hydrogen, who's working on hydrogen? Okay, so electrolysis, everything. Okay, good. Who is working on power electronics and control? Oh, this is very little. Okay, you are actually the best of my audience, so, because this is mostly what most of the systems are about. So when you are, of course, working on the materials, you have to understand, I think this is really important, the system and what the system does. And I think maybe, even though my presentation is very simple, it might help you actually in the end. So to define a benefit, we have to ask the customer who is using our batteries or our, let's say, energy storage solutions, let's say. So first of all, the people buy a functionality. They don't buy a hybrid battery. They don't buy, they usually buy an energy storage solution, a solution. Yeah. So I think in somehow a thing that stores electrical energy, somehow they're not interested in how it's done. They want to have a certain, they have a functionality in mind. Yeah. But what kind of functionalities do we have? So first of all, I think it's very, very well defined in the definition from the European Union about energy storage. And this is actually a deferring of the final use of electricity to a moment later in time. So it's a shift in time. So energy storage actually makes energy available due to a shift of time. Before, the definition was actually often it's an energy consumer, an energy generator, which didn't connect the storing part and the, let's say, generating part together. So it's just separated them, which caused a lot of trouble, legal trouble, and so on. But now we have, luckily, this new definition, which says that energy storage shifts energy in time. You know? So when we have this functionality of shifting energy in time, we have to actually look also on the place where we position our storage. You know? And there are definitely 2 very big distinctions. One is, of course, already Roberto showed a lot of use cases, but you can somehow dissect stationary energy storage in two fields. One is grid connected and off-grid. Yeah? So off-grid means, so grid connect means you have your battery somehow, or your energy storage system somehow. I wrote here a redox flow battery storage, but it can be any system. So somehow connected to the grid, so to a landline, or you have an island where you are not connected. And if you are grid connected, of course, we have this in front of the meter. So shown here in this little graph. So you can be connected in front of the meter, so directly to the grid. So it's operating with the grid, and these are defining the use cases. Or you can operate directly behind the meter, so with your local source of electricity, like renewables, locally, so not interacting with the grid. So the first task for you, because we want to make an interaction, is I have here some typical use cases. And your task is now to define what is the state-of-the-art technology in this. What are we doing? So what kind of technologies do we use, for example, frequency regulation? Anybody of you? Yeah? Sorry? Yeah, there are some mechanical uses. That's true, but so like spinning generators. Yeah, true. Other things, when we think of energy storage, anything else? Sorry? LFP, yeah, so somehow lithium batteries, let's say LED, lithium batteries, that's true. So energy shifting. What does it mean, energy shifting? We shift energy from, for example, in the morning to the evening. What kind of storage do we use there today? Sorry? Pumped hydro. Yeah, pumped hydro. This is a good one. And it's actually really the most used part. So now comes new applications. So we have two applications like peak shaving, peak shifting. These are relatively new applications. Stefan, you know it. Yeah. For what? For peak shifting? That's. This is also a big shifting from day to day. Yes, we have actually, of course, intraday markets where lithium-ion batteries play an important role today. That's true. So, but also peak shaving, peak shifting, relatively new applications, not so much used. Sorry? If you have short peaks, we use actually sometimes on a very local level supercaps. It's true. Flywheels, not so much. But if you look at larger peaks, like a few hours, then a flywheel is depleted or supercap depleted very fast. What else do we use? Yeah? Yeah, we could, but then we need, usually an electrolyzer is not so flexible. It's really, operating an electrolyzer is usually you try to run it 24/7 because otherwise it's not profitable. You need your full load hours for an electrolyzer. So the typical, actually, for a lot of these answers, Stefano already said it, it's lithium-ion batteries. So for peak shaving and peak shifting, mostly lithium-ion batteries for short duration peaks. Also some supercaps in smaller applications, but usually smaller supercaps are unfortunately very expensive. So actually lithium-ion batteries. So island power supply. How do we power an island with an energy storage solution? Well, what do we do currently? What's state of the art? That's right, diesel. The diesel generator, yeah. Power to please explain. You mean hydrogen? Hydrogen. Is it really state of the art? We want to use it, I guess. But look at the island. Look at Mallorca, no, or Ibiza. How do we power Ibiza? Sorry? What? Yeah, of course. These are, let's think of smaller islands. I mean, Ibiza is maybe a bit big. There can be a coal or gas power plant. Smaller island. A little, what is a small island in Norway? Solar cells, yeah, but we're talking about usually how do you provide? So, of course, in small island, we use diesel generator or also sometimes now lithium-ion batteries more and more. So for most of the answers, it's actually lithium-ion batteries. For microgrids also, of course. So shorten it a little bit. Heat storage. What do we use as heat storage? Now the heat storage people, you can shine. What? So do we use a latent heat storage? I think not yet. So what do we use currently? What is water? Yeah, water storage. I think actually this is the most used storage so far. It's water storage, no? Because water has a high heat capacity and okay. So first of all, we define some application. We have some use cases. So the question is, if I make my hydrogen storage or my hybrid storage in one of these applications, we need to be better than this application. I think this is important to understand. Yeah. Let's go to the next slide to understand. First of all, when I'm a customer, why do I buy stuff? This is an easy and a very difficult question, actually. What drives my decision to buy a hybrid energy storage? So actually, I've made once a sales training, actually, for scientists. And in this sales training, they told me there are three reasons to buy something. One is definitely cost. Something is cheaper than the rest. Yeah. The other one is safety or security. You tend to spend more money when it's safe or secure because the cost, if you don't, are higher. So it's a kind of also, if you have to pay later because something is really more expensive, you want to be on the safe side. This is how insurances work, actually. So they sell you that you have to pay now less because if you don't, you pay more in the end. And the third one is prestige. Yeah, I mean, you buy an iPhone not because it's the cheapest phone on the market. You buy it because it transports something else. And in this, we have to say sustainability is also a prestige reason because you cannot find another reason why you buy for sustainability. You buy also prestige. So these are the three dimensions why you buy a product. But of course, this cost part can have more sub-dimensions. Yeah. So if my hybrid energy storage has a better performance, then you get more for maybe the same money. Then actually you save costs. You have to sell it, of course, not so easy. If you have a higher efficiency, this also is very interesting for the customer because inefficiency, he has to pay. Yeah. Usually in a storage, when you store electricity, you have to pay once the cost for generating the electricity, and electricity is never for free. Don't be fooled. Electricity costs something. Yeah. So there is a cost always allocated with electricity. If you have a higher efficiency, then you can store much more, so you have less losses. So higher efficiency is one important part. Increased lifetime. Usually costs of storage are called in levelized cost of storage. So it's over the complete lifetime of the system. So increased lifetime is super important. Sometimes you can save a bigger investment. Usually in Germany, for example, we have a Swabian Alps where you have very loose power connections. If you want to build a factory there, you need power. If you buy a storage solution, you can at least cut the cost to build a new power line for a certain time. In the end, you have to build it, but you can push it to a later state. So you can make a capacity investment on a later stage, which can also save cost and be an argument. So, what is seldom the case for HES storage is that you have a cheaper system or a simplified system. Usually, hybrid storage is more complex, more, so usually also cost quite a lot. So usually the last point is not so much applicable for hybrid energy storage. So, of course, the application is, for my friend, one of the most important stuff. And for this application, you usually design an energy storage solution. Often when you hear, for example, flow battery people, and I'm coming from flow batteries, they say, oh, you cannot build a lithium-ion battery storage for longer duration than 4 or 6 hours. This is rubbish. You can always design a storage. Storage is always designed to the application. So I can make a long duration storage out of button cells. Yeah, it's just a design. I have to design it, and it won't be a good storage because the button cells will deplete very fast. But it's a design choice usually. So this is the important part. So and usually that's why KPI comes always. So key performance indicators come into place to understand better why one certain technology is better for the application than the others. Yeah. And maybe you heard already about key performance indicators. One big part in storage project is, of course, to find key performance indicators. And key performance indicators, I think this is important to understand. We have 2 different key performance indicators. We have one key performance indicators of your energy storage, and we have requirements from your applications, which are not the same. And I want you to understand this. This is a very big, important lesson, which is often, I fear that it's mixed up when we talk about performance indicators. Yeah? For example, when you are dealing with batteries, energy density is one of the most important issues or most important indicators you're always asked about. But actually, the customer is not interested in energy density. He has a volume available for storage. This is actually the requirement from the application side. I have a volume. Yeah. So this is different. So this is application, and this is your energy storage system. They are not the same. So my task for you, find the requirement for the application. So I think you learned something. I hope you can read it. It's not too small. So for example, gravimetric energy density. What would be the corresponding requirement in the application? It's very similar to the upper one, so it's an easy first one. Yeah. Yeah, mass. Correct. I have to change my glasses. 1 second. Where is it? I have it here. Ah, nice. Okay. Yeah. Thank you. The next one. So the next one is nominal power density. What could it be for the application? Yeah. Required power. Yes. Maximum power density. Yeah. Yeah, please. Could be. Yeah. I think it's even easier. So required maximum power. Yeah. This is really, of course, it has to do also with frequency regulation. You can also, absolutely right. Thank you for this. It's also, but I think it's more general to say maximum power requirement. So the battery capacity I leave out, but maybe area footprint. Area footprint is something you hardly hear when you design batteries, but it's actually more important than energy density for stationary application, at least. So what is area footprint. What would be the requirement for the system? Try to formulate it. Just a reformulation of what's written. Yeah, compactness or land use. Land use, actually, yeah. So yeah. Now response time. What is response time actually? How fast it reacts to certain changes, yeah, in power. So what would be the requirement from us if you have the eye of a, I want to have a storage of a customer. So can you repeat? Amperate. Yeah. Good. Yeah. So C rate. This is really tricky. We make it C rate at the end because C rate is really tricky. Let's go to lifetime first. Yeah. So capacity and C rate is actually C rate is a bit tricky. Cycle life, galvanostatic. So this is typical requested for when you write a scientific paper. You make galvanostatic cycle. How many cycles can you get? But what is the relation to really an application? What if I am a customer? Am I really asking you? Yeah, correct. This is actually for both. So the lifetime, and this is the same with calendar life. Yeah. Okay. So shelf life. What is shelf life actually? What does it mean?
Use.
Correct. Yeah. So,
I'm not at all.
Yeah. So usually you have here two things. Percentage of capacity decay in idle mode and shelf life. Shelf life is actually meant when it's completely not used. And capacity decay is when it's actually in idle mode. So they are slightly, it's nearly the same, but slightly different. But actually the requirements from the customer is nearly the same. What could it be? Yeah. Lifetime? No, it's not lifetime what is meant. No. Yeah, but it's
Energy retention.
Energy retention. This is correct. Why is it not a lifetime relate? Because it's capacity decay. It's a reversible capacity decay. It means when you have charged a battery, how long can it hold the charge? Not over in general, but in this initial charge. How long can it hold? So this is meant here. Maybe a little bit. I have to rewrite it a little bit. But I think it's energy retention is a good place. You would ask. So now the last one are sustainability. What would you ask as a customer for this? Yeah, toxicity is definitely one thing, but it's not really mentioned with critical raw materials and recyclable raw materials. Actually, here, yeah. So actually, sustainability would here be the, I think, what I have thought here. Sorry? Fairness of trade. Yeah, in a way. Yeah. This would be fairness, yes. Okay. Now comes the magical question, C rate. This is difficult, actually. So is a customer first interested in C rate, actually? In a way, yes. He wants to have the power capabilities of his batteries. So how would you connect it to a customer need? Yeah. This would be more efficiency, actually, reversibility. No, it's really the power capacity. So how fast can it deliver power actually? And the question is actually, this is a layout question. The C rate, yeah, so it's actually power, how would you call it? Power. But this is also, in the end, it's a layout question. I can do it with very slow storage solution. If I ramp it up, continuous power. Yeah, I would also say continuous power. This is correct. Okay. So I'm very happy with what you came out with, and I am coming to the end with what would be, in your opinion, good use cases for hybrid storage, where you really get a benefit, say you can really get a benefit. So maybe I go back to the slide with some of the use cases. Can you name me a use case where you see a hybrid could make absolute sense? That's one idea, yeah. For what kind of application? Yeah, but you have to be careful. The question is, if I buy a supercapacitor and a lithium-ion battery, single systems, what is the benefit of hybridization compared to single system? I have the problem always, we had a big discussion internally in one of the projects where we had, for example, first look, for example, for demanding loads like motors, where you have usually a power spike due to a starter. And then, of course, a supercap can reduce the spike. But the question is, if we have two individual systems, it does the same, yeah? So where is the benefit of hybridization there? It's a good answer, but it doesn't satisfy me completely. Maybe up there. Yes. Yes. Of course, I mean, it's a good application, but what is the difference between two individual systems? This is a hard question, actually. So it's really not so easy. Oh yeah, 5 minutes. Okay, I have 10. Oh yeah, I will be fine earlier. So this is a discussion point here. It's really important to understand. So if you have, as I said, if you have a demanding load, you can have two individual systems in the grid. Do you get a benefit? Yeah. Yeah. But what could be, let's go back here to the slide. This here. Can you point to the point where you would say, I can sell it to you? Which would be the point here where I can sell it to you? Sustainability. Really?
Increased lifetime.
Increased lifetime. This is always a good thing. Increased lifetime is one point. For example, we had the discussion about a pump hydro with a flow battery. Here, the flow battery would be the short duration storage, and the pump hydro is a long duration storage. And this has to do because the cycles of the pump hydro were so demanding so that you have to, the machines wear off more. So the flow battery could increase the lifetime of this complete system. Who said lifetime? Who said this? So you can decide, fresh or blue. What is the least evil? Blue? Okay, yeah, you got it. Last comments of blue. Yeah. Who wants to have crash? So now another. I have to point here to one of these parts here. Battery performance. Yeah, but give me an example where you have maybe better performance. But don't be fooled. If you have two individual systems or a hybrid, what is that one? But this is really, we had long discussions about this, really long discussions. Where is the benefit of a storage when it comes to really selling? Yeah, give me an example for security. When is it important, security? Yeah, backup is a good point. Backup is actually a very good point. Backup. Also, we identified backup as one of the really parts where hybrid energy storage could play an important role. Why? Today, backup solutions are mostly half an hour and just secure, usually, especially in larger applications, just secure that your control is safe. Yeah? But in principle, you could today back up bigger parts, especially data centers or something which is really important. And then sometimes you could work with combinations like lithium-ion battery storage and redox low battery, where you can guarantee an UPS solution on a longer life, on all time scales. Yeah? Who said backup? You Mrs. Fresh now. I hope you like it. So yeah, it was entitled to you. Even I didn't show you any graph and any data. Thank you very much.
So are there any questions? Any further question to Peter Fischer? We see 5 minutes.
So that I have a question.
where's
Yes.
I was betting on higher efficiency.
On higher efficiency? As a yeah.
You save a lot of money.
Absolutely, absolutely.
Right, if I plug it up.
Yeah, please plug it up. Yeah. Absolutely. Efficiency is also a good point.
Give the mic.
Efficiency, I can speak loud. Yeah, you can give me a buck, yeah.